It's just a little bit of review in case you forgot over the break. So we learned that the orbitals actually have much more complex shapes than just being perfect circles like you might have been taught before. So like for example, the s orbital has a sphere shape. The p orbital has a shape that kind of looks like an infinity sign. The d orbital looks like a four-leaf clover. And the f orbital looks like what we call a double clover. So they get more complex as we go down. All right. Then we use this chart to help us figure out the electron configuration for elements. So titanium is number 22. So the top number tells you the number of total electrons there are. So Ti has a total of 22 electrons. So I need 22 electrons. So let's start at the top of our chart and work our way down. And I've kind of already highlighted the path so that you can adjust to the way it moves. So I'm going to start at the very top, follow that diagonal line, and then go to the next and go to the next. You always follow the diagonal lines from back to front. So it'll be 1s2. Next line, next arrow, 2s2. Then start at the back of the third arrow, 2p6. And the way that I know how many electrons can fit into each of the orbitals is my key that I have on the side. So the s can fit 2. That's why next to every s at the top I put a little 2. And then the p, that's why I put a 6. Okay, so let's keep going. After 2p moving forward, it'd be 3s, 2. Then you'd go to the back of the fourth arrow and work your way down. Then it'd be 3p6. Keep going, 4s2. Then go to the back of the next arrow. And then we'd start with 3d. Now I'm going to stop right there. Let's count how many we have. We have 2, 4, 10, 12, 18, 20. So all we need is 2 more. Now if you look at the D can fit up to 10 electrons. But I don't need it to hold 10, I only need it to hold 2. So we don't have to use all of them. We only have to use as many as we need. Okay, so 3D2. And we're done with Ti. The next one is Br. So Br is over here to the right. And now Br has 35 electrons. I think some of you are getting confused with valence electrons and just electrons. So valence electrons is given by the group number. So Br would have 7 valence electrons, but total electrons, it has 35. The atomic number tells you the total electrons. So we're going to follow the same pattern. We're going to start at the very top and we're going to work our way down through those diagonal lines. So it'd be 1s2, then 2s2, then 2p6, then 3s2. Go to the back of the next one, 3p6, then 4s2. Keep going, 3d10. This time we're going to use all of those 10. And let's stop right there. 2, 4, 10, 12, 18, 20, 30. So right now I have 30 electrons. I need 5 more. So keep going forward. 4p6. But we don't need the 6, right? We only need 5. So we'll do 4p5 to add up to 35. Okay? Now, let's just practice how you would go if you needed to add more. So let's say you needed to keep going. You had an element that had more. So after 4p, you'd go into 5s. When you're done with that, you'd go to the next arrow, start at the back, 4D10, 5P6, 6S2. Go to the next arrow. Let's say you needed to add even more. 4F14, 5D10, 6P6, 7S2, and so forth. Okay, so you always follow that pattern and you work your way down. Okay, now we're going to move on to new information. So we're going to be looking at molecular geometry, bonding pairs, lone pairs, hybridization, and bond angle. So molecular geometry has to do with the way the atoms or those circular balls are organized. So if we look at this one, if you look at the digital version, I'm going to draw that. This is how you would draw it. The molecules are in a straight line. So the shape of this is called linear. Bonding pairs are the pairs that are connected through those lines. So that's a bonding pair and that's a bonding pair. They're being bonded between those two circles. So we're going to have two. Lone pairs, we're going to see in a minute, but this one doesn't have lone pairs. Lone pairs you will see as two little dots or two electrons that are alone on their own. They're lone pairs, they're alone. So there's none here. And hybridization is going to be a mixture of the s and the p orbitals. Okay, so you want to look at how many items are attached to that center atom. Well, we have 1, 2. We have two things attached, the two bonding pairs. So we're going to have 1s and 1p. And this will make a lot more sense as we work through these. If you remember from math class, whenever you have a straight line, the angle for that line is 180. So going from one atom to the next is going to be 180 degrees. That's our bond angle. The next one we see here is no longer linear. The arms are bent downward, right? They're bent downward. So this is going to be bent. And I'm going to put a little 1 because this is a special type of bent. This bent one has one lone pair. Do you see those two electrons I drew? So in our drawn image, the bonding pairs are going to be the lines that connect the atoms or the balls, those little balls we see. So we have 1, 2. We have two bonding pairs. Then let's look at lone pairs. Lone pairs are those electrons that are alone. But remember, a pair, like a pair of socks, is made up of two. So we're going to see that there's only one lone pair. The hybridization for this is different. We want two bonded pairs plus one lone pair gives us a total of 3. We have 3 things attached. 1, 2, 3. So that means we're going to need 1s and 2 p's to add up to 3. So sp2 is the hybridization. The bond angle of this is going to be 120 degrees about. And you can imagine this from a circle. So if you look at a circle is 360 degrees. And we're splitting that circle into 3 equal parts. So it'll be about 120 degrees, the angle. The next one we're going to look at is just the same as what we did before, but it's a tad different. This is also bent, but this is bent too. Instead of having one lone pair, it has 2 lone pairs. So bonded pairs, again, are the lines that are connected between the atoms. So that's 1, 2. We have 2 bonding pairs. Lone pairs are these pairs that are alone. There's 2. And the hybridization, you always only get one S, and then you use the P's to add up to how many you need. So 2 bonded pairs and 2 lone pairs, that's a total of 4. So 1S plus 3 P's will give us the 4 we need. The bond angle of this is about 109 degrees. Okay, the next one, the name actually makes sense because of the way it's shaped. So you have 1 in the center, and then you have 1, 2, 3 atoms attached to that center atom. So this is called trigonal planar. Bonding pairs, again, are the lines that connect the atoms. So there's only 1, 2, 3. The lone pairs, in this instance, there's none. The hybridization will then be S, P. So let's think. 3 bonding pairs, 0 lone pairs. We need to add up to 3. So 1S plus 2 P's will give us the 3. Just like before, on our sp2 over here, the bond angle will be 120. So sp2, 120 for the bond angle. Again, think of a circle being separated into 3 equal parts. I didn't draw this as best as I could, but each of these will be 120 degrees, equally separated. The next one is going to be called trigonal pyramid. So trigonal pyramid kind of looks like a pyramid. Now the way we draw this is a little different. To make it look 3D, we draw one as a wedge, is what they call that thick line, a wedge. We draw one just as a normal straight line, and then we draw one as a dashed line. So the one that's a wedge, this one that I'm drawing, or I'm looking at right now, connecting, that big thick wedge, that one's coming towards you, like it's coming out of the page. The dashed one to the back is behind the page, going away from you. And then this other one is towards the side, the one that's just a straight line. And if you look at the digital version, you see those 2 electrons up at the top for being a lone pair. So bonded pairs, we have 1, 2, 3. Lone pairs, we had 1. So our hybridization has to add up to 4. So it'll be always 1S, and then you'd need 3 P's. So like before, for our sp3 here, the bond angle is about 109 between each of the atoms. Our last one is going to be called tetrahedral. It's a little bit of a long name. So we're going to have 1 in the center, one that's a wedge, like if it was coming out of the page, one's a dash going behind the page, and then a straight line, and then one at the top. So bonded pairs here, we're going to have 1, 2, 3, 4. Lone pairs, we have none. So the hybridization would be you always only get one S, and then we'd need 3 P's. Alright, so then the bond angle would be just like before, 109 degrees between each of those atoms. And that squiggly just means about, so it's about 109. Alright guys, so that's it. I'm going to have this uploaded as well as the notes for in case you want to look back at these.